We've got a good number of tests written out so far. I think we should do just one more test that really captures everything our campaign does from start to finish. So I want to take our campaign, I want to contribute to it, I want to create a request, I want to approve the request, and then finalize the request. And then at the very end, we should be able to assert that some other party received some money from the request. This is going to be a pretty good amount of typing for this final test that we're going to write, so let's get started right now. I'll add on a new it block, and I'll give it a description of it processes requests. We'll then place our async keyword and get started. So again, the first thing we have to do is contribute some amount of money to our campaign. I'll say await campaign.methods.contribute, and then I will attempt to send some money in, and we'll say that this is going to come from accounts at 0. To make this a little bit easier to test, we're going to send along a whole bunch of way, because generally it's easier to test changes in account balances when we are moving around large sums of money. If we're moving around just like 100 or 200 way, that amount of money usually gets lost in the thick of things when we compare it to gas prices. So if we want to make sure that we are moving around money, usually easiest to send along a good amount of ether. So in this case, I will send along 10 ether. And remember, anytime we want to specify ether, we're usually going to make use of the web3 module. So I'll say web3.utils.toWay. And I want to convert 10 ether into way. And I'm going to send that along with the transaction. Okay, so that looks good. Now that we have contributed and marked accounts at 0 as a contributor, we can now create a request. And in that request, we will attempt to send some amount of this 10 ether to another account. So right after this, we'll say await campaign.methods.create request. Now, just as before, I think request is going to end up being a kind of a long line with a couple of different arguments. So I'm going to new line it right away. Remember that create request takes 3 arguments: the description, the amount of money we're trying to transfer, and also the target account to send it to. The description doesn't really matter in this case, so I'll just put in A, like so. Doesn't really matter. But we do want to make sure that we specify an appropriate amount of money to transfer and an appropriate account, because we're going to eventually look at this target account and verify that it has received some amount of money at the very end of this test. So I'm going to say that I want to attempt to transfer web3.utils.toWay, and I'm going to try to transfer over 5 ether. So out of the 10 that I just sent into the contract, I want to attempt to send 5 of it to this other address. And in this case, we're going to attempt to send that 5 ether to the account accounts at 1, like so. Now we've only called create request. We have to remember to send it as a transaction as well. So I'll add on send. This will come from accounts at 0. And as usual, we will specify our gas as 1 million. So this right here should create our request to attempt to send 5 ether to accounts at 1. Before we can attempt to approve or finalize this request and make the actual assertion, we have to remember to actually vote on this thing. So we have to attempt to call our campaign's approve request method and attempt to actually say, yep, this looks good to me. It can be sent. It can be finalized. Go for it. So before we attempt to finalize it, we have to vote on it. We'll say await campaign.methods.approve request. So remember, that was a function that we spent a pretty good amount of time on. Here's the function right here. So we call approve request, and we specify the index of the request that we want to approve. In this case, we've only created one request, and that request must be at index 0. And then, of course, we'll send this with this very repetitive statement. So we'll say from accounts at 0 and a gas of 1 million again. All right, we're almost at the end here. So now that we have approved the request, we can now finalize it. Remember, we can only finalize this thing because out of the one contributor we have, so here's finalize request right here, out of the one possible approver we have, they have already voted yes. So essentially 1 out of 1 people have voted yes on this thing, which means we can successfully finalize the request and have the money be sent to this other recipient. So underneath approve request, we'll do await, campaign, methods, finalize request. Just as before, we have to pass in the index of the request that we want to finalize. So we're going to pass in 0, and we will send that in. So from accounts at 0, gas 1 million. Again, we are making use of accounts 0 here because in theory, only the manager has the ability to actually finalize the request. All right, so after calling finalize request, that should disperse the money from the contract over to accounts at 1. So now the last thing we have to do is retrieve the balance of accounts at 1 and verify that it does in fact have some additional amount of ether inside of it. So the last thing we have to do is to retrieve the balance of that account. Remember, we can retrieve the balance of any account on the network by using await web3 eth get balance. And then we pass in the address that we want to check as the only argument. So in this case, I want to get the balance of accounts at 1. Now, just as before, when we call get balance, this returns a string. So we have to take the string, we have to turn it into ether, and then we have to turn it into an actual number that we can use to make a comparison. So that's going to be maybe 2 or 3 lines of code. So I'm going to assign this thing to a variable called balance. And note that I'm using the let keyword here because we're going to do some reassignment of balance. So at present, balance is a string that represents the amount of money that accounts 1 has in way. So the first thing that we'll do is we'll take that balance and we'll turn it into ether. So we'll say web3 utils from way, and we pass in balance, and we specify that we want to have ether. Now balance is going to be a string represented by, or that is representing some amount of ether. And we can't really do an easy comparison with a string, so the last thing we have to do is turn this thing into a float. So I'll say balance is parse float, and I'll pass in balance. If you've never used parse float before, it's a built-in helper included with JavaScript. It takes a string and tries to turn it into a decimal number. So now balance should be an actual fully qualified number that we can do a comparison on. So at the very bottom, we can finally say we want to assert that balance is greater than some minimum amount of ether that this account should have at this point. Now here's the tricky part. One thing that we have not been super clear on about Ganache inside of our tests so far has been exactly what happens to Ganache and our list of accounts in between tests. Inside of our test helper up here at the very top, we very clearly are redeploying our factory and our campaign between every test run. However, there is nothing at present that resets the amount of money that any account has between test runs. So in other words, we don't really know exactly how much money accounts at 1 should have at this point in time. Because if some earlier test said, hey, take all of this account's money and send it somewhere else, then at this point in our tests, accounts at 1 would have like 0 ether. In other words, we are not properly doing cleanup of our accounts list between tests. And unfortunately, that's kind of at present a limitation of the Ganache network that we are making use of. So ideally, we would be able to do a full restart between every test, but again, it's just not easy for us to do right now. So in other words, we have to be aware that accounts at 1 might have like, who knows how much ether. Now, just because I know exactly how these tests are working, I know personally that accounts at 1 at this point in time probably has around 99 ether or so. So just to make sure that my tests pass and allow for some float here, some changing of accounts 1 balance in case I ever come back and adjusting these tests, rather than saying that accounts 1 should have like greater than 105 or exactly equal to 105 ether, I'm just gonna say this thing should have like at least greater than like maybe 103. And maybe I could even do 104. And in fact, let's print out balance before we actually do that comparison and just kind of get a sense of how much money actually belongs to accounts at 1 at this point. All right, so let's run our tests and see what happens. So we'll do npm run test. We will wait just a second or two. All right, so right here, this is the balance of accounts at 1. And you'll notice that it is not exactly the 105 that you might expect it to be. So in one of the earlier tests that we executed, I think we used accounts at 1 to issue a transaction. And when that transaction was issued, accounts at 1 had to pay for it in gas. So like I said, that gas that got paid doesn't really get cleaned up in between tests that we are running. Only the contracts do. So this is why we're kind of using that little bit more flexible amount that we are using for the comparison. That's why we're using 104 right here, rather than saying very rigidly, oh yeah, this account should have like exactly 105 ether at this point. Now in theory, we could use some other account besides accounts at 1 that we've never touched before, but honestly, that would just lead us into issues later on as we start to add on more tests, because maybe later on we start to make use of that other account, and maybe we start spending money or withdrawing money or sending money to it, and eventually a comparison between that account and 105 being completely equal would eventually fail as well. So we're just going to be a little bit flexible here and leave it to say accounts at 1 should have at least 104 ether. I know this entire system right here of comparison between accounts seems like it's very prone to breakage. Honestly, writing this test feels really bad to me. I don't really care for this one bit. But unfortunately, we just don't have a lot of workarounds or easy to do improvements here. I'm sure at the end of the day, we could think of some really clever way of handling this, but at present, we just don't have a lot of built-in functionality in the entire Ethereum world for writing the best tests in the world. Maybe at some point in time that'll change, but for right now, we're kind of stuck with this slightly more sloppy approach that you see right here. Okay, so at this point, we now have 6 tests passing. Like I said earlier, I'm sure we could think of dozens more tests to write. You know, we could try maybe writing another test that says like, oh yeah, let's try to finalize the request without approving it. Or let's try to have someone who is not the manager approve a request, or not a contributor approve the request, or someone who is not the manager finalize a request, or any other number of test cases. So of course, we could think of all these different types of tests to write. But at the end of the day, for the purposes of this course, I'm sure you don't want to be writing tests all day. So if you want to write more tests on your own, I absolutely encourage you to. I really, really, really encourage you to write your own tests, because it'll give you a much better understanding of how to make use of Web3 and manipulate the contract. But if you want to just move on to writing the actual application, which is pretty darn exciting, I will say, then feel free to pause here and continue with me into the next video.